Welcome to Tech Blueprint, a window that lets you know the latest technology news in the world. As we all know, due to changes in the external environment, wafer fabs like TSMC and Samsung have lost the ability to freely ship to the outside world. To further align itself with advanced American chip design companies, TSMC has begun building its own wafer fabs in the United States to provide foundry services to local clients. However, with the rise of Chinese chip foundry giant SMIC, the prospects for TSMC, the world's leading chip foundry, appear to be diminishing. Recently, new news has emerged from Samsung in South Korea, suggesting a situation TSMC has been reluctant to see unfold. It is understood that following TSMC's announcement to establish a chip foundry in the United States and provide advanced chip foundry services to local companies, Samsung in South Korea also announced plans to catch up in advanced process technology, aiming to catch up with TSMC in this area. However, Samsung's overly ambitious goals led to setbacks at process nodes such as the 5 nanometers and 3 nanometers processes. Inadequate chip yield control has led to abnormal leakage in the chips produced. The resulting chips are far from matching TSMC's advanced process technology in terms of both power consumption and performance. This has led to a rapid decline in Samsung's share of the chip foundry market. In the first quarter of 2025, Samsung's chip foundry market share was only 7.7% of the global market, while SMIC held approximately 6%. Unable to compete with TSMC in advanced foundry technology, and unable to compete with mainland Chinese wafer fabs in mature process technology, Samsung's market share has rapidly declined. To address the decline in its chip foundry business, Samsung has made adjustments to its chip foundry operations this year. According to reports released by South Korean media, Samsung's foundry division has decided to postpone the iteration of its next-generation 1.4 nanometers process, and will invest more funds in refining existing processes to improve product yield. This means that TSMC will face even more intense competition with Samsung in the 5 nanometers and 3 nanometers chip foundry markets. Furthermore, there are reports that Samsung has signed a $16.5 billion chip foundry agreement with a mysterious major customer, valid from now until the end of 2033. According to industry analysts, this major customer is very likely Tesla, as the two parties have previously collaborated on automotive-grade chips and even conducted research and development on smart driving chips. Samsung's efforts to improve the yield of its existing process and sign an agreement with a mysterious major customer are precisely the situations TSMC least wants to see. First, TSMC's share of the advanced foundry market is primarily due to its cost advantage. If Samsung's improved process can achieve costs similar to or even lower than TSMC's, It will quickly replace TSMC's chip foundry business. The two competitors' chip foundry businesses are similar, and even if Samsung fails to steal TSMC's loyal customers, leveraging its existing production capacity will weaken TSMC's bargaining power, hindering its ability to maintain revenue growth in its advanced foundry business. Secondly, Samsung may partner with more American companies, gradually replacing TSMC's position in the US market. It's no secret that the US prioritizes support for its chip foundry business, especially Intel. However, Intel encountered difficulties developing advanced processors, and before it could enter large-scale production, it burned through its R&D funding. After its failed attempt to support domestic companies, TSMC's importance to the US began to become increasingly apparent. If Samsung could achieve the same effect, TSMC would soon face replacement by South Korean companies. This is the situation TSMC most dislikes: a loss of its uniqueness and distinctiveness in the US. Finally, unlike Samsung's focus on advanced process technology, mainland Chinese manufacturers are currently making greater efforts in mature processes. Not only have these advanced processes been improved, but yield control and costs have also been reduced to above-average levels. This means that TSMC, which has established factories in the US, will no longer be able to expand its revenue share from mature processes. At this point, TSMC has only two options: either secure free shipments to China or maintain its leading technology and market position. Otherwise, both Samsung and the catching-up mainland Chinese wafer fabs will face jeopardy in their market positions. A breakthrough in key core technologies would deal a crushing blow to their competitors. What are your thoughts on this? Feel free to leave a comment and discuss.